Welcome to the Introduction to Machine Learning course. Hi, my name is Michael. I'm the founder of the Student Machine Learning Coalition, and I'll be one of your instructors throughout the duration of this course. Now, I want to start by asking a question. What do self-driving car systems, stock price predictors, and game AIs all have in common? The answer is simple. They all involve, in some shape or form, machine learning. Now, machine learning may seem like a big, mysterious concept, and often ways it's treated as such. Hopefully by the end of this course, we'll have demystified it in a fun, concise, clear way. So let's go over what I'm going to be talking about through the rest of this session. First, this is pretty much going to be an introduction to the course. We're going to ask, what is machine learning? Next, we're going to go over the goals of the course. Then we're going to go over something called Kaggle, which is a platform that will be heavily involved in this course. And then we're going to go over the course overview. That means going over exactly what the sections are going to be and why they matter. And then in another video, I'm going to cover Google Colab, which is the platform that we'll be using to actually write our notebooks and write code. So to begin, what is machine learning? Now, there's a lot of jargon out there if you search up machine learning, big data, deep learning, reinforcement learning, and that's all important. But it can be overwhelming at first. So I want to go over what machine learning is in its simplest terms. And that is getting patterns, predictions, actions from data. So I think this diagram can kind of explain how machine learning operates in this context. Now, oftentimes you'll have data, for instance, historical data for the prices of houses, or you'll have data in terms of having a camera footage. These are all instances of data. They can be historical, they can be instantaneous. But what machine learning does is it takes this data and then it allows you to do multiple different types of operations. What does this mean? This means predicting the price of a house 1 month in the future, say, given historical data. Or it could mean classifying what object or what objects exist in an image and what types of objects they are. It can mean finding clusters or groups within data, and it can even mean training an AI to interact with its own environment given goals and rewards, say in the Snake AI. Now, machine learning pretty much encompasses all of these terms, and we'll go over exactly what the different types of machine learning are in future lectures. But ML is a very quick, rapidly growing industry, and hopefully we'll be able to discuss the nuances that set you up for success in the future. But now let's ask, why is this important in the first place? Well, we already know that it's spreading to every industry. We already know that it fuels life-saving research, for instance, preventing collisions within cars. But I think there's also something that's very just interesting about machine learning. And I think one of the founders of machine learning, Herb Simmons, you can see him over there. He's got this really great quote. I don't believe that predicting the future is really what machine learning is about. We are going to be a part of the future. So our task isn't to predict it, it's to design it. And so I think this is a really inspiring note that what we're doing with machine learning really does have a bigger purpose. It means helping others. It means doing research that could have positive impacts on society. And so I think machine learning, beyond its the beauty of elegant algorithms, really does have a place for good in the world. And I think another thing that's important that often gets left out of the discussion is that really anyone can learn machine learning. It's not just something with people. It's not something for people with high mathematics degrees or computer science degrees. Really, anyone can learn, and hopefully, you will be the proof of that. Okay, so the goals of this course are pretty simple. We want to go over the theory and the fundamentals because those are always important, but we also want to go over the practical implementations. And so throughout each of the different sections, we'll be going over exactly why we're doing the things we're doing, kind of what intuits, what the different algorithms we're working with, but also how do we actually use them in the simplest way possible? Like, what do data scientists do on a daily basis? But another thing that we think is unique to this course is that you're going to submit to your first Kaggle competition by the end of the course. And so that probably raises the question, what is Kaggle? So let's go over that. Kaggle is the most used platform for data scientists and machine learning enthusiasts pretty much on the internet. And so it's got a bunch of different features to it. You can access data sets, you can ask questions on forums. There's also code sharing through what they call kernels. But what we're going to focus on is competitions. And so competitions are a big part of what Kaggle is. It's for novices and PhDs alike to work on real world data to really actually not just see the algorithms in terms of equations, but see them in terms of results, in terms of predictions. And so there are different types of competitions. You've got novice competitions. There are prize competitions as well. So novice competitions don't really award any money. They're more for just the fun of doing the competition and for the skills that can be acquired. But there are prize competitions. I think some of them actually award, say, $100,000 or a job if you place within the top or you're in the money. And so these awards can be useful. For instance, some of them award jobs, and they can also be useful in the sense that you get some money. But I don't think we should be doing competitions just for the sake of getting money. Obviously, that's great. It's also just for the sake of practicing skills and being able to work on real-world data. Now, competitions can be hard, and oftentimes people don't finish their first submission because of that barrier to entry. So that's what this course really is here for. And we're going to submit to the Titanic competition by the end of this course. Okay, so let's go over exactly what's going to happen. So here's a little roadmap that discusses the different sections of this course. You can kind of split them up into 3 different parts. The first part kind of covers the prerequisites needed to do machine learning. And so that means going over Python. If you don't have experience with Python, that's totally okay. You can still take this course. Hopefully that will catch you up to speed on what is needed to know for the rest of this course. Then we're going to go over some libraries used within Python. For instance, NumPy, it's a very popular library. Pandas, it's important. Seaborn for visualization. And then when we have all of those done, now we're going to delve deep into machine learning. So we're going to start off with a quick introduction to machine learning that goes a bit more in depth than this one. And then we're going to go to the actual algorithms. And so one of the important ones are linear regression, logistic regression, k-nearest neighbors, decision trees, neural networks. And then in the next section, the 3 section, we're going to go over some more practical parts, some things that are a bit more advanced. So that means ensembling, the different ways you can do ensembling. It also means competition tips for if you want to do competitions. And then we're going to close with some final thoughts. Okay, great. So this is pretty much what I wanted to cover in this lecture. Please stick around for the next video where we're going to actually go over what Google Colab is and how to use that. So see you then.